this one, again, the first thing to notice is that we're trying to find extrema. So anytime we're looking for extrema, we're usually looking at where is the derivative equal to 0 or does not exist, and then drawing a number line with our critical numbers labeled. Now, when we take the derivative here, the derivative of 2 standalone constant is going to go to 0, and then the 2/3 is going to come down, and then we'll have x to the negative 1/3. And as we said before, when we're doing this whole f prime is equal to 0 does not exist, it's good to kind of keep in mind that we want f prime as one fraction, and we do not want negative exponents, because honestly we don't really know how to deal with negative exponents very well, and so it's easier just to make them positive by moving them down into the denominator. So what we'll do to start to find our critical numbers is we'll move the negative exponent down to the denominator to become a positive 1/3. And then now, once we have one fraction, we just set the numerator equal to 0, so 2 is equal to 0, and the denominator equal to 0, 3x to the 1/3 is equal to 0. Now, from 2 is equal to 0, we get absolutely no information. Over here, you could just say that x is equal to 0, and the reason for that is because if you divide by 3, you are going to get x to the 1/3 is equal to 0. Then to undo this 1/3 power, we would raise both sides to the reciprocal, which would be 3 over 1. But if you raise 0 to the 3 over 1 power, you just get 0. So you are going to get x is equal to 0. All right, so with that critical number, we then draw our number line. And it's probably easiest if you work with the one fraction derivative. So we had 2/3 x to the 1/3 power. All right, so keep in mind that this is the same thing as the cube root of x. So you can use your scientific calculator to plug in a number here, but you just have to have some way of figuring out the sign. So for example, if I plug in -1, I am going to have 2 over 3 to the cube root of -1. And the cube root of -1 gives us a negative, so we have a positive over a negative, and so we just get a negative. Now, if I plug in a number to the right of 0, let's say I plug in 1, in that case, I have 2 over 3 cube root of 1, and there is not a negative in sight, so that is going to evaluate to positive. So we have a positive. All right, so looking at our number line, remember first derivative tells us increasing and decreasing. So this negative tells us that we are decreasing until 0, and this positive tells us that we are increasing after 0. So 0 will be a relative min for us. Now, to find the corresponding y value, you need to plug it into the original function, the original y. So our original y was 2 plus x to the 2/3. So plugging in 0, we will have 2, and I'll write here 2 plus 0 to the 2/3. So we will just have 2. So our relative min is going to be equal to 0, 2. And if you look at the structure of this graph, that is actually the lowest point the graph ever will have. So that actually is an absolute min as well.